Hello everyone, this is the 6th lecture on organic chemistry, and in this lecture we are going to discuss alkynes. So as you know, the general formula of alkynes is CnH2n-2. So this is one of the analogous series of hydrocarbons. So the alkynes are those hydrocarbons which contain a triple bond between two carbon atoms. For example, C triple bond C, here we have H and H. This is the first alkyne, that is known as ethyne, or it is also known as acetylene. So acetylene or ethyne, both are same. Ethyne is also called acetylene. The common name of ethyne is acetylene. So if we talk about the sources of alkynes, so alkynes, similar to the alkenes, they are also obtained from petroleum products or natural gases. Now the next is nomenclature of alkynes. So in the nomenclature of alkynes, we have already discussed the nomenclature of organic compounds. You know that in organic compounds there is a triple bond between two carbon atoms. So the suffix that we use here is -yne, Y-N-E. For example, C triple bond C, we have two hydrogen atoms here, so its name is ethyne. Its IUPAC name is ethyne. Similarly, if we have CH3C triple bond CH, so it will be called propyne. It will be called propyne. Now similarly, CH3C triple bond C CH3, so it will be called but2-yne. Why 2? Because the triple bond is at second carbon atom, so therefore it will be called but2-yne. If first carbon atom forms a triple bond, then its name will be but1-yne. So what will be its name? Its name is but2-yne. So I hope you have understood how to give the names to organic compounds, how to give the names to alkyne. The next is the structure. If you talk about the structure of ethyne, so you know that in case of ethyne, in ethyne you have a triple bond. So carbon atom has 4 electrons in its outermost shell. So two carbon atoms share 3 electrons each, and 1 electron is shared with hydrogen atom. So 1 electron is shared with hydrogen atom. So this is how it forms a triple bond, and 1 bond with hydrogen atom. Two carbon atom will form 1 bond with hydrogen atom. Now it will share its 3 electrons. The other carbon atom will also share its 3 electrons. So a triple bond will be formed between these two carbon atoms, and a single bond will be formed with the hydrogen atom. So both the carbon atoms will form a single bond with hydrogen atom. The next is the preparation of ethyne. However, it will not be the part of syllabus in 2020-21, but there are very few reactions. So let's see. The first is preparation of ethyne from calcium carbide in laboratory. So this is the laboratory preparation of ethyne. So we use calcium carbide, CaC2. This is calcium carbide. So on treating calcium carbide with water, what will we get? We will get calcium hydroxide plus ethyne. You can see here we have ethyne. So this is how we can prepare ethyne from calcium carbide. So this is calcium hydroxide plus C2H2, that is ethyne. So we treat calcium carbide with water and we will get calcium hydroxide and ethyne. The next is the preparation from 1,2-dibromoethane. So what is the name of this compound? 1,2-dibromoethane. Now when 1,2-dibromoethane is treated with alcoholic potassium hydroxide, this is alcoholic potassium hydroxide. So on boiling 1,2-dibromoethane with alcoholic potassium hydroxide, we will get ethyne KBr, that is potassium bromide and water. Now how does it form ethyne, potassium bromide and water? So this reaction is also called dehydrohalogenation reaction. Dehydrohalogenation means removal of hydrogen and halogen will take place here. What is halogen here? Bromine. So 1 bromine, 1 hydrogen, 1 bromine, 1 hydrogen. So 2 hydrogen atom and 2 bromine atoms will be replaced. So 2 hydrogen atoms are replaced and 2 bromine atoms are replaced. So it will form CH triple bond CH like this, C2H2, and the 2 bromine atoms will combine with potassium and 2 hydrogen atoms will combine with OH. So it will form 2H2O. It will form 2H2O. So I hope you have understood this reaction. The next is the preparation of ethane from methane or natural gas. So how can you prepare it from methane? By pyrolysis. You know what is pyrolysis? In this reaction, the methane is heated at very high temperature up to 1500 degrees Celsius with the help of electric arc, and it will result in the formation of ethane and hydrogen. So you can get ethane and hydrogen from here. So this is how you can prepare ethane with various methods. The next is chemical properties of ethane. So what are the chemical properties of ethynes? Means how the ethane will react with different substances. So the first is catalytic hydrogenation. Means hydrogenation. I have already told you about the hydrogenation, that is addition of hydrogen, and catalytic hydrogenation means addition of hydrogen in the presence of catalyst. So what will be the catalyst here? The catalyst that we use is generally nickel or platinum. So we will use nickel here, and hydrogen, when hydrogen is added to ethane. So you can see this is ethane and hydrogen is added to ethane. So one hydrogen atom will be attached to this carbon atom and other hydrogen atom will be attached to this carbon atom. So it will become CH2. You can see here CH2 double bond, triple bond will be converted to the double bond. So it will become CH2 double bond CH2. You know that the name of this compound is ethene. So what will we get first? Ethene. On further hydrogenation means on adding hydrogen further, what will we get? The double bond will be converted to single bond and it will form ethane. You can see here nickel is the catalyst here. So it is treated with hydrogen at 300 degrees Celsius and we will get ethane. The next is halogenation. As the name suggests, halogenation, addition of halogen. So in the presence of carbon tetrachloride, the reaction will take place in the presence of CCl4 when the chlorine is added. So in the similar way in which the hydrogen was added, the chlorine will also be added. So what will happen here? The chlorine will react with, this is your ethane. So the chlorine will react with ethane. So one chlorine atom will be attached to this carbon atom, other chlorine atom will be attached to this carbon atom. So which compound will be formed? What is the name of this compound? This is 1,2-dichloroethene. Why ethene? Because there is still double bond. So 1,2-dichloroethene, not ethane. Its name is 1,2-dichloroethene. Now on further reaction with chlorine, because still we have a double bond, so there is a chance of breaking this double bond. So this double bond will be broken and a single bond will be formed between the carbon atoms. So you can see again one chlorine atom will be attached to this, other chlorine atom will be attached to second carbon atom. So what will we get from here? You can see there are two chlorine atom attached to first carbon atom, two chlorine atom attached to second carbon atom. So what will be its name? 1122 tetrachloro, 1122 tetrachloro ethane. Now because there is only single bond, it will become ethane. So 1122 tetrachloro ethane. It is the IUPAC name of this compound. The next reaction is reaction with bromine. So as it reacts with chlorine, in the similar way it will react with bromine. So you can see here CH, triple bond CH in the presence of carbon tetrachloride. So in the presence of carbon tetrachloride, what will happen here? One bromine atom will be attached to one carbon atom, other bromine atom will be attached to other carbon atom. So what will be its name? Instead of chloro, it will be bromo. So what will be its name? 1,2-dibromoethane. What will be its name? 1,2-dibromoethane. Similarly, on further addition of bromine, it will be a double bond, right? On further addition of bromine, what will happen? Again, one bromine atom will be attached to this carbon atom, other bromine atom will be attached to second carbon atom. So what will be its name? You can see again 1122 tetrabromo, 1122 tetrabromoethane. Now it will become ethane, and in previous case it was 1,2-dibromoethane. So you have to be careful about this. So this is the reaction with bromine. Similarly, on reaction with iodine. So Iodine does not react very easily with ethyne, so it will form diiodoethene. It does not react further with diiodoethene, so the reaction will end here. So I hope you have understood the chemical properties of ethyne, the reaction of ethyne with hydrogen and halogens. Now on further, you can see the reaction with halogen acids. So reaction with halogen acids, what are the halogen acids? You already know, HCl, HBr, etc., HF, HI. So these are halogen acids. So how does the ethyne react with HCl? So you can see here we have two parts, H and Cl. Now hydrogen atom will be attached to one of the carbon atom and chlorine atom will be attached to the other carbon atom. So you can see the triple bond will be broken to a double bond. It will become a double bond. So what will be its name? You can see here CH2, CHCl. So what will be its name? Chloroethene. Its name is chloroethene. Again, on further reaction with HCl, the double bond will be converted to single bond. Same reaction will take place at it was taking place in the previous compounds with the previous compound. So what will be its name? You can see there is only single bond, and again the hydrogen atom will be attached to the same carbon atom and the chlorine atom to which the chlorine atom was attached in previous case. So the two chlorine atoms will be attached to the same carbon atom, not two different carbon atoms. So what will be its name? Its name is 1,1-dichloroethane. It is 1,1-dichloroethane. Similarly, the reaction will take place with HBr. The hydrogen atom will be attached to one carbon atom. The bromine atom will be attached to other carbon atom. Triple bond will be converted to double bond. So what will be its name? Its name is bromoethene. Now this bromoethene will further react with HBr. Now the double bond will be converted to single bond, and what will be its name? Its name is 1,1-dibromoethane. Its name is 1,1-dibromoethane. The next is reaction with ozone. So how does the reaction with ozone take place? So you can see here CH triple bond CH. You can see here on reaction with ozone. What is the formula of ozone? This is ozone. Ozone, the formula of ozone is O3. On reaction with ozone, you can see 3 oxygen atoms are here. Now the triple bond will be broken. The carbon atom will be attached to 2 of the oxygen atoms like this. These 2 oxygen atoms are attached to each other, and one of the oxygen atom will be attached to both the carbon atoms. So this compound is known as ozonide. So what will be its name? Its name is acetylene ozonide. Its name is acetylene ozonide. So this is how the ozonides are prepared. This is how the reaction with ozone takes place. The next is combustion. So you know that hydrocarbons on reaction with oxygen, on combustion, the hydrocarbons will give carbon dioxide and water. So this is the reaction. So you can see here, all you have to do is to just balance the reaction. So C2H2 plus O2 will give carbon dioxide and water. So ethyne on reaction with oxygen, on combustion, it will give carbon dioxide and water, and a large amount of heat is also evolved. The next is oxidation with dilute alkaline potassium permanganate. So on reaction with dilute alkaline potassium permanganate, the oxidation of ethyne will take place. So you can see we have ethyne here. Now dilute alkaline KMnO4 acts as an oxidizing agent here. So it acts as an oxidizing agent. So on reaction with nascent oxygen, which is given by dilute alkaline KMnO4, so on reaction it will give COOH double bond COOH. What is the name of this compound? This is known as oxalic acid. So its name is oxalic acid. The next is reaction with ammonical cuprous chloride and reaction with ammonical silver nitrate. So ammonical silver nitrate and ammonical cuprous chloride, both reactions are similar. So you can see here CH triple bond CH on reaction with CuCl and NH4OH. This is known as ammonical cuprous chloride. So it will form, you can see hydrogen is replaced by copper. So its name is copper. It is known as copper acetylide. Copper acetylide. So remember the name of this compound, and further it will form, the chlorine will combine with NH4, so it will become ammonium chloride and it will give water. Now similarly, on reaction with ammonical silver nitrate, the reactions are quite similar. So AgNO3 when treated with, this is your ethyne, so this is silver nitrate and ammonium hydroxide, this is known as ammonical silver nitrate. So on reaction with ammonical silver nitrate, it will give, the hydrogen atom will be replaced by Ag. So what will be its name? Its name will be silver acetylide. Its name is silver acetylide, and again it will give NH4NO3, that is ammonium nitrate, like it forms ammonium chloride here, so here it will form ammonium nitrate and water. So this reaction is also used for the detection of Ethyne. So the color of copper acetylide, that of silver acetylide is white color, so it will give a reddish brown precipitate, while this will give a white color precipitate. So I hope you have understood the reaction of these compounds. The last topic is uses of Ethyne. However, this year it is not the part of syllabus, but it will be included next year. So uses of Ethyne. What are the uses of Ethyne? The first is, it is used in oxygen acetylene welding. So it is used in gas welding, which is known as oxygen acetylene welding. So it is used in welding. The next is artificial ripening of fruits, like ethene is used in artificial ripening of fruits. It is also used in artificial ripening of fruits. It is also used in the manufacture of many organic compounds. You can see the chemical reaction of Ethyne, so it can be used in the manufacture of many organic compounds. For example, here we can prepare oxalic acid from Ethyne, or we can prepare the halogen derivatives from Ethyne. So it is also used in the preparation of many organic compounds. It is also used in the preparation of synthetic products like rubber, synthetic fibers, etc. So this is all in this lecture. I hope you have understood all the properties, physical properties and chemical reaction of Ethyne. If you have any queries, you can ask your questions in comments. Thank you very much.